Hi, welcome to this lesson on trigonometry compound angles. Let's have a look at the sine compound angles. So again, we said that there's a set of important trig identities known as the compound angle formulae, or sometimes referred to as the sum or difference laws. And this time we're going to have a look at the sine compound angle. So before we do that, let's recall that we proved earlier that the cos of A minus B was cos, sine, then angles as you see them, AB, AB, and then the sign in the middle, if it was minus, you put a plus, and if it was plus, then you would put a minus. Okay, so the signs just changed, but it followed that rhythm. Now for sine, we have a similar rhythm. So sine of A plus B, you can write as sine cos sine, and the angles as you see them, so AB, AB. But this time sine follows the nice convention that the sign in the middle is the sign you get. And then similarly for sine of A minus B, we have sine cos sine, and then the angles AB, AB, and where it's subtraction in the middle, we get subtraction. So let's go ahead and prove that, and we'll prove it from the cos compound angle formulae that we derived earlier. Okay, so to prove the sine compound angle formulae, we'll note two following properties. Firstly, from co-ratios, we can write sine alpha as cos of 90 minus alpha. So let's just remember on your cast diagram what that looks like again. Okay, so if here's alpha, right, so some points here, drop a perpendicular and create a right angle, then the sine of alpha would be this opposite over this hypotenuse. So the sine of alpha would be that opposite side over the hypotenuse. So if we call this coordinate pxy here, then have a y height and a x length. So it's going to be y over, and the hypotenuse, if we call it r, so it'll be y over r. And then cos of 90 minus alpha, well, 90 minus alpha is this angle here inside the right angle triangle. So the cos of 90 minus alpha is adjacent, which is that side y, over hypotenuse, which is r. So from co-ratios, these are equal to each other. Okay, then the next property we'll use is the cosine compound angle formula, which we derived earlier. So for sine of A plus B, we'll write it as cos of 90 minus A plus B using co-ratios. Okay, but now I'm going to group the terms like this. So I can rewrite this as cos of, if I distribute that negative, it's going to be cos of 90 degrees minus A minus B. So now I'm just going to group 90 degrees minus A into one side here, and there's still minus B on the outside. Okay, so now we have a case of cos of an angle minus another angle. Okay, and we worked that out using the compound angle formula for cos. So we said it's going to be cos sine, then the angles as you see them, 90 minus A and then B, 90 minus A and then B. But cos of 90 minus A by co-ratios is sine of A. And sine of 90 minus A, that is co-ratios as well. So sine changes to cos of A. So we've proven that sine of A plus B is sine cos sine of the angles as you see them, AB, AB. Okay, so that is successfully proving sine of A plus B is sine cos, or sine A cos B plus cos A sine B. So you can see sine pops up twice and cos pops up twice. And it's just that the angles alternate. So where you have sine A here, you have cos of the other angle B. Plus where you have cos A here, then you have sine of the other angle B. And then similarly, we can prove that the sine of A minus B is sine cos sine of AB, AB, where the sign in the middle is negative. Okay, so we'll use the first sine compound angle formula to prove the second one as follows. So again, we'll write sine A minus B as sine of A plus negative B. But we know what sine of angle plus an angle is. We just worked it out. We said it was sine cos sine of the angles as you saw them. So A and negative B, A and negative B. Okay, but cos of negative B by the even trig identity is just cos B. And sine of negative B by the odd trig identity for sine is negative sine B. So cleaning this up algebraically, we have sine A times cos B minus cos A times sine B. Okay, and that is proving the sine A minus B compound angle formulae. Alright, so now that we've gone ahead and did the cosine and sine compound angles, we're going to have a look at how we can use them in various forms in trigonometry, from simplifying to equations to trig graphs and so on. Alright, I'll see you in the next one.